Great, welcome back. I was talking to Scott Pilgner on a bus ride yesterday, and he said something that I actually thought about a lot of sense, that when it comes to issues of computation in design, the inputting of data is not the problem. I mean, we have an enormous amount of information that we deal with, and we have keyboard or a mouse, and we can inputting the data is not the issue. It's projecting the data outward, and the various modalities of data projection are now the issue that we have to think about in design technology. And some of the issues that are the rubric of what we call design technology. Of course, issues of sustainability that we already ended the morning with, or the last panel with. Issues also of fabrication, it was also mentioned. But then there's, we start thinking about at the GSD different kinds of office practice and how offices themselves could be outfitted with projection technologies and display technologies that are adequate to office practice in a contemporary sense. And then of course issues of pedagogy. How do teaching technologies, how can we redesign the way we teach to take advantage of new teaching technologies? And all of these issues and more are under the rubric of what we call design technology, which is the subject, and the future of design technology, which is the subject of the next panel. Andrew Witt, who got both his Master of Design Studies and Master of Architecture at the GSD, has curated the panel. I'll just quickly introduce them before I turn it over then to Andrew. So Kiel is Assistant Professor of Technology at the GSD, also an alum, whose specialization is in energy and environment. Neil Denari, all of you know, of course, at LA. His office is in LA, but also Professor of Architecture at UCLA. Andrew Atwood is founder, along with Anna Niemark, of First Office here in LA, and also teaches at SciArc. Alice Kimm founded with John Friedman an office here in LA, and is the director of the undergraduate programs at USC. Wes Jones, also office in LA, has taught many times, is a really good friend of the GSD, and comes out often to do, as a design critic. And then Panagiotis who is assistant professor of architecture, specializing in computation and computation geometry, teaching at the GSD. So thank all of you for coming. We really appreciate it. And thanks to Andrew Witt for curating the panel on the future of design technology.
Thanks, Michael. Is this on? Is the amount of
No.
on?
No.
Yeah. Up? Is this better?
A little bit.
So getting there? All right. Better? Yeah. Perfect. Okay, good. So thanks very much for the introduction, and obviously for the opportunity to assemble some profound thinkers on this particular subject. I'm delighted to be a part of this event. So today, of course, we're going to be talking about design technology and the use of computation in the context of a design school and practice, but I think it's important to contextualize design technology within the sort of broader trend of technology in our society. I mean, today we're basically 6 decades into what you might call the computer revolution, and that's had, of course, vast impact within design, but also much broadly throughout our society. So, for example, today knowledge is increasingly organized and shared digitally. Computer-automated making machines have fundamentally reorganized the way that labor and material is allocated and operated on. Computer-generated fantasy images are so seamlessly mixed with reality that we scarcely distinguish between them any longer. Our capacity to manipulate and make things from materials has absolutely soared. So if you look at, say, the volume of industrial production since the 1950s, it's absolutely skyrocketed. And of course, with that, the impact, the sort of ecological impact of that, of those types of processes. So technology is deeply impacting today both human endeavors and the resources needed to achieve them. And it's funny, I think high technology in particular has sort of taken over this glamour position in our thinking about technology today. Mark Andreessen, who's founder of Netscape and very sort of influential venture capitalist, has said that today software is eating the world. I think what he means by that is that software as a tool of reorganizing processes, people, and knowledge is really fundamentally impacting the way we do things. And so this panel is all about that sort of phenomenon in design. So in design, new software tools and making tools have of course dramatically broadened the range of what designers think of as being possible. So all the projects here are projects that I would say 20 years ago would have been less conceivable than they are today. And these are all projects that I've been involved with in one way or another in professional practice at Curated Technologies. So Curated Technologies is sort of the research group of Frank Gehry's architecture office that has been sort of spun out to as a sort of technology transfer to the rest of the design world. And so we're involved with the realization of projects like this through technology. So on some level, technology has helped bring about what Frank calls the waking dreams of designers. It's made those closer to reality than ever before, but at the same time, it's forced us to grapple with exigencies about the fundamental aims, means, and objectives of design, as well as some epistemic questions like what it means to know about design, what the scope of design knowledge is. It invokes some basic questions about space making, materials, detailing, tectonics, as well as, of course, this broader set of environmental and epistemic issues. So those types of issues are often manifest in process, in the idea that technology can make the downstream constraints or more extensive constraints of making a building more present in the process of design. Now, this idea that technical systems, mathematics, geometry, things like that can be are fundamental to the process of design is, of course, not something that's new. And in a way, I wanted to give a little bit of context of what we're doing today in design computation. I want to provide a context that extends a little bit further back. The school today, I think, engages in questions of design, computation, technology, both as speculative concerns connected with issues of representation and practical matters and spheres of potential invention. So particularly on the fabrication side, the use of computation and technology is really an opportunity for designers to create entirely new materials, processes, ways of making buildings. But of course, these concerns are have been very present with design since the advent of modernism. So just to give you a little bit of perspective on where, as Moisen said, the school is a very sort of, it's a very diverse project. And to give you a little bit of perspective about my specific interest in these topics, I think I can talk about maybe two courses that set the stage for what we'll talk about today. So there's sort of two paths of investigation for how design technology impacts form. The first is really an investigation into geometry itself and its connection with computation and technology. Essentially, it's a course that investigates spatial problems as historically recurrent and also geometrically constrained. And then we ask in the class, how can we take those constraints of geometry, those constraints of making, fold them into our digital models, and essentially make a more elastic design process. So that class often is about thinking about the implicit structures of form, the processes of actually assembling that form, the particular constraints in terms of industrial production that make those forms possible, and then creating a concurrent understanding of all of those problems in order to create spaces that actually solve many problems simultaneously. So these are a few student projects from that class. Second class is actually a sort of second path through the relationship of computation and design. It's a class that actually examines the fundamental processes of making and asks, are the machines and materials that we have at our disposal as designers, can we go beyond taking this for granted and actually make machines that create the effects that we want in terms of material behavior? So this is a project, for example, where students essentially built their own computer-controlled fabrication devices, where they sort of took plastic and suspended in it metal fibers, and then with electromagnets began to activate and deform and shape that surface. So really a sort of basic look at how materials are connected with computation and making and how that actually expands the scope of design intervention. So Los Angeles, of course, where we are today, is a particularly unique context, I think, in which to discuss these issues, because LA is sort of the cradle of advanced mechanical technology. But it's also a cradle of fantasy. Stars and astrophysicists commingle in a city where truly anything seems possible. It's a place to develop ideas and, I think, above all, to experiment. With space, with the city, with making, and with design. And it's no coincidence that some of the earliest provocateurs in this sort of dialogue about digital design emerged here, as well as a fundamentally new relationship between architecture and how it represents itself through, say, motion and animation. So Los Angeles is a city of makers. It's a playground of both precision and excess, of possibility and illusion. And it's in that context that we welcome our esteemed panelists to consider the fantasies and waking dreams that might be possible through this future of design technology. So I asked the panelists to basically submit an image that maybe positioned them in some way in this dialogue. And so I'll just show those quickly, and we'll proceed maybe to this dialogue. And the dialogue is intended to be a very sort of open and fluid exchange, a debate even at times, I expect. And we'll also at the end conclude with opening up to questions from all of the guests. So this is Atwood, Kiel, Wes Jones. Some of these I'm actually curious myself what the specific position being taken in, but I'm sure that that'll be interjected actually in the course of the conversation, which I'm looking forward to. Alice Kimm. So I think one of the most fundamental connections actually between design computation and sort of an approach to sustainability is this topic of simulation. So simulation, I think, has become sort of one of the key modes of understanding buildings today. We simulate, for example, perspectives, visual images of the building, which we also simulate a whole range of other aspects, structural aspects, and of course environmental aspects, not only of the building itself, but its larger urban context. Of course, Los Angeles, in a way, is sort of the birthplace of a lot of that simulation as well, sort of the birthplace of simulated cinema experience, and so forth. So simulation, conceived broadly, has really become ubiquitous in design. And I think one of the major questions around simulation today is what the appropriate context and most promising applications of simulation might be, and what aspects of simulation might be most provocative for design in the future. And I think inherent in that question is also a question of risks and limitations. I think when it comes to technology, there can be always there can be a sort of evangelism that can take things beyond their appropriate context, and so I think it's reasonable to think about what the limits of technologies like simulation might be in the future and stuff. Actually, I received some responses in advance from Wes, and so I know that he's prepared with responses. So I actually wanted to begin with him, this question of simulation. And
so now I have to try to remember what it was I said earlier.
No, well, I have it here also. So.
Maybe we could just have you read it. The issue of simulation, for me, has two interesting aspects. One is that on the good side, in theory, as the technology for simulation becomes more advanced, we ought to be able to experience our designs in their entirety before they actually become realized out in the physical universe. And so that should, therefore, logically lead to those designs getting better and better and better. We don't have to commit our mistakes out here where the rest of the public is subjected to them. And so therefore, in a way, the whole underlying ethical dimension of architecture as a profession is brought into question if you can ensure that confrontation is always going to be more positive than less, because you're not committing those mistakes in public. On the other hand, though, as those simulations become better and better, the necessity to actually realize those things in physical space goes down. And with it, the influence that architecture has traditionally enjoyed for characterizing the way that we are in the world is lost to other mediums as media, simulation and all. And so, on the one hand, it should allow us to make architecture better and better, but there may be a tipping point where we actually end up preferring the virtual dimension, and architecture just becomes sheltering. It becomes an engineering problem again rather than an architectural problem.
It's actually on that point. I think this sort of like fine line. I think there's after probably several decades, there seems to be this. I don't know if it's rapprochement, but this sort of reconvergence of concerns around engineering and architecture. And I think it's a very sort of fraught problem. And one of the things, actually, one of the remarkable things that I know Panagiotis is doing is actually taking on this project of the emergent properties implicit in structural systems and thinking about how those might inform design. And I'd be curious actually to know your perspective on this topic.
Well, I think that simulation is more useful as a pedagogical tool in the context of the university, but in practice you do need different disciplines and practitioners that can actually make sense of the simulation results, because there's a big danger of oversimplifying and misunderstanding what the simulation tells you. My experience is that working, for example, in structural engineering software and writing such software that makes complex methods more accessible to designers, what's important is that this modifies the designer's intuitive understanding of what the problem of structure is. So it's not about optimizing this or that structure or solving a particular problem, but changing our intuitive understanding of what it means to distribute material in space. And designers are fundamentally intuitive decision makers, so simulation won't give them definite answers. And because design problems are basically non-optimizable, the outcomes are rather fuzzy and rather characterized by multiplicity. In that sense, we still need designers, we still need engineers. I had in a conference, which was an engineering conference, architects started asking, so since our structural engineering simulations become so perfect, when will be the point that we won't need structural engineers anymore? And the engineers replied, when you will be able to sign the drawings, when you will be able to take responsibility for it.
Still need a warm body for that, huh?
So it's important to have an agent that takes responsibility, and so you do need a designer or an engineer for that reason.
Yeah, I think the question of modifying intuition is an interesting one, because the proliferation of simulation tools actually, it makes it possible to develop that intuition in a whole range of different directions. I mean, you could have a structural intuition, you could have a sort of energy-centric intuition, you could have a sort of fabrication intuition, and often those things have, I think they're sort of contested directions. They're competing directions, right? And so I think one major question is actually to what extent out of those contested directions should that moment of truth when the designer sort of invokes an active will to create, where should that come? When should the designer bracket actually those other intuitions and say that there's actually something more fundamental for the role or for the life of the project? In particular, one of the things I'm curious about is kind of like this not competition, but sort of feels like implicit conflict between the will of the designer in a way and something like I don't know, something like sustainability. And I mean, I've had sort of like my contact with sustainability, as you can probably guess, is sort of marginal. But I think there's some sense in which there's some sense in which, in order obviously to create something that has a sustainable ambition, certain other ambitions need to be checked. And I'm just kind of very curious about the role of sustainability, in particular sustainability simulation.
Well, I don't think that would be the position of people who are championing sustainability. I mean, I think that at its most basic level, sustainability is just a newly recognized part of the contract we make as professionals with the world to do the best work. And this is just another dimension to that we didn't appreciate before because we had this excess capacity, let's say, or there are fewer of us or whatever it was. So I think that the way to view that would simply be this is another element that you have to deal with as you're solving a complex architectural problem. Not that there necessarily needs to be a competition between, or a competition beyond the normal competition that occurs in the design process between all the different elements. I think it's only a matter of time before that also just gets worked into the mix in a regular way. In the meantime, of course, it becomes an opportunity for those who are super into it and have the expertise, either as a source of profit or as a source of inspiration, formal inspiration.
At the same time, I totally agree. It is another sort of requirement, let's say, of design thinking today. But it's very important, from my perspective, that we construct an architectural agenda for things like energy and environment that we've completely lacked. We basically capitulated to engineers and building physicists about these sorts of topics, which are often very lacking. I mean, right now, the discourse on simulation or energy is tied to ideas of efficiency, which is a false agenda for energy and runs against the principles of architecture. So in this sense, we need a much more ecological understanding of what energy is in an environment. So if you follow that line of thought, then we need maximum power designs. We don't need efficient designs by any means. This whole idea of energy efficiency is so absurd because it violates the first law of thermodynamics, right? So how could you construct an energy discourse on something that violates the first law? It doesn't make any sense. So we need completely other perspectives that I think build upon the necessary excess of architecture. We still have an excess of energy, and you look out that window and blinded by how much sunlight is coming in. This is still 99.97% of all the energy that we get is from that sun. So we still have this excess, and architecture still needs to be operating on this excess. So I think that that's important to understand. But within this realm of simulation, especially regarding energy, which is structures, it's more manageable. Visualization, it's more manageable. Construction, it's more manageable. But energy is really complicated. And so most energy models are as incomplete as they are inaccurate, and therefore, in my mind, only serve to answer very small questions. So we still need this much larger perspective, I think, that the architect, the designer, tends to provide the world. And so we can't just continue to, let's say, pawn off this part of the discourse to adjacent disciplines.
Yeah, no, I wouldn't say that at all. I mean, I would totally agree with you in the sense that the architect is responsible for giving expression to all these issues, for either through the sense of order arrangement or through the actual physical shapes of things. If you leave it to the quantifiable realm, you trend toward ultimate efficiency, but of course, architecture as the realm of expression is definitively counter to the interests of efficiency. Architecture is all that happens after you've solved or satisfied the questions of efficiency, and every step out of efficiency or beyond efficiency is into architecture. So there is a fundamental conflict there. So, and the architect, as Corbu said, you're not a drawing board artist, you're a manager. And then the idea of the architect as the impresario, the person who puts all this stuff together, knits it all together, means that the awareness of this as an issue will be an architectural problem.
Yeah, I think absolutely this kind of like question of the architect as a coordinator, as an impresario, as all of those things is something that we need to address in the context of fields which increasingly really demand a sort of technical competence that requires training. I think actually some aspects of sustainability are like that. I think some of what's done in design geometry and fabrication actually requires some sort of deep technical knowledge. And I think that actually there's two aspects of that. Of course, there's a sort of need to reconfigure pedagogy in order to support that development. But I think there's also a question of, in the professional context, how do you equip your practice to really learn about those ideas in an efficient way? Actually, that was one thing that I was curious to get Alice's perspective on, because I know that you've done quite a bit in actually helping your practice to learn about those about clean technology and those types of things.
Before I sort of answer that, I just did want to say to what Wes just said, I don't know if, because I think as a practitioner it's really important to kind of understand how you talk to or to have a position with which you address your clients. And so the idea that architecture and efficiency are in conflict with each other, I think in a way is something that you can't actually say to the client, because then they're always going to go with efficiency and forget about the architecture. So I think that one of the things that we look at in our practice is always to frame it more in the sense of all of these things kind of somehow being in balance. That no one thing is ever 100%, because that is not how you get the best architecture, or the best building, or the best function, or the best anything. And so how can you actually begin to frame discussion for your clients that sort of allows all of these things to coexist in a way that makes sense for everybody. So I think balance is one thing, and I think in terms of sort of working with buildings that in name have something to do with technology, we've done some work at Caltech. We just finished a new sustainability institute there, and we're doing a clean technology campus downtown. What's always interesting is that in name the projects sound so much as if they must just lend themselves to addressing these issues fundamentally from the point of design. But in fact, it comes down to those same things. It comes down to policy, it comes down to politics. It very often comes down to budget, probably more than anything else. So again, it's really to what degree can you really affect or become a player in this kind of balancing game between energy efficiency and design. I think one of the obvious things is that we're all collaborating. It's much more of a collaborative relationship with our engineers now, and so we bring that the engineers are really an integral part of the equation. I suppose that we, in some ways, still see ourselves as being the directors of this kind of game, but at the same time, the engineers who we enjoy working with most are as invested in this idea of a balance between all parts as we are, and so I think that's sort of where, for us, it comes down to.
Yeah, I think kind of this question of policy is a very sort of rich one, and I think particularly today, as actually many aspects of at least building become more quantified. There's an aspect of policy that becomes sort of more and more central to what architects and designers do. And I think especially today around thinking about possible futures that would enable sort of intelligent use of energy, that enable sort of intelligent use of materials, that enable a society that actually is achieves those goals that we have set for ourselves in terms of sustainability. I think the public is kind of looking for visions around what that might be, and I think that to some extent architects could provide those, but I think it's an open question about whether we should, and if we should, how.
Why would we not?
I'd be devil's
I mean,
advocate.
traditionally it's been our job to do that, to provide the world with a sense of how things were or should be. I think it has been a couple hundred years that we've been losing ground in that influence to other media, and I think that sadly that trend is only going to accelerate with Moore's Law and the capabilities of the media and the simulation and this sort of thing. But to the extent that we still continue to put stuff out there in the world in people's face, unavoidably, I think we have to take on that responsibility. And I think, until technology gets to the point where, the world of goggles and gloves is more compelling than the physical world, we have lots of opportunities there that the physical world will continue to be has the haptic dimension that the virtual doesn't have, and it will continue to be compelling in a way that gives us, a megaphone.
But it's interesting though, because the tools that are used to create those haptic immersive environments are now the tools that we use to create buildings. So the buildings that we've created actually have a very, in a way, public aspect to their computational or technological approach. That was actually, one of the things that I thought was really compelling about your project, your Highline project, was that it actually has a very public space, exposes some certain ideas about technology and its relationship to the environment. And I was actually curious on some level what the sort of public response has been to that, if they sort of understood what the architecture was trying to communicate.
We got into the politics of sustainability like right away, which is great. It's probably going to color everything. Vis-a-vis simulation, one thing I wanted to try to put back on the table, Michael's introduction on everybody has data. What do you do with it? We all have data. Big office, small office. We have consultants. They're nerds behind the scenes working things out with us. The ambition is over the top. It's incredible. Alice mentioned issues of clients, so I wanted to talk about simulation at the level of visualization. It seems as though today every student is expected to actually deliver a discourse on realism. When we were trained, abstraction ruled. You could have a white cardboard model and go, trust me. And today, there's no trust. So simulation actually, and by the way, I never practiced as a white cardboard model person. I always practiced as, I want to have the highest level of realism possible. So for me, I don't find any disappointment. I never apologize for rendering like a lot of architects do. Capitalization to the commercial or something like that. So we tried to build a building that was better than the rendering, and usually the thought is it can never be as good, right? Material life is too diabolical, too problematic. You can't coerce it into a level of, let's say, effective resolution. But I think we did with that building. I think that project has a kind of, well, in New York it's hard to build a tight building, and we pushed tolerances beyond belief because we had it simulated digitally, because we had 90% of the building built in a factory through hands and robots, put it together in a way that would be much more foolproof than if you were building it part by part, stick by stick, in an old-fashioned way. So we had the condition of the simulation of the image, and the life of that project existed for 6 years before it actually arrived as a real thing. Set up for disappointment, and my whole ambition was to push back on the disappointment and make a building which could stand up to the fantasy of the image.
I just want to say one thing about, I teach primarily, and so my concern, just to respond to something that Neil said about the fantasy or the fallacy of the sort of high resolution, high fidelity image, and the way that I've seen that trickle down with my students as we've begun to work on things where it's hard to imagine anything other than a kind of abstract realm, and that has to do with physical computation and robotics. And I think what they end up thinking, and I think what they bring to it is that they're somehow solving a problem and presenting a project as if it was a kind of high fidelity version, or adding knowledge in a way that the thing is a kind of one-to-one translation. And in fact, the best, I think, and this has to go with the sort of, I think, the strength of simulation tools, and that, by that I mean robots to actually allow us to simulate fabrication technologies. Goals of sort of high resolution, high fidelity fabrication done solely by architecture students are valuable, only, to my knowledge, only in their understanding of how that might be how their own design process, they might speculate and simulate how that plays a role in a larger process, so they can sort of design, fake, fabricate using these robots, as opposed to a sort of expectation that they're going to develop a new technology with these new tools that is somehow as good as what you might get with people who have been working with robots for 30 years. And so I think you have the connection between that and let's say a rendering, or a rendering that tries to explain exactly what the thing will be like, is much closer than I think people think. And the dangers of it, in terms of the way that it's sort of found its way into digital fabrication, and specifically with robots, which are much more generic in what you can do with them. They're much more open-ended platforms. The realm of speculation and simulation is more sort of profound, and there's much more space to do that in than with like a 3-axis CNC router. But it's that maintaining a certain level of distance or abstraction with those tools, in the way that I would hope people would think with their drawings and with their renderings, and the sort of knowledge learned in an abstract realm, is just as important now as we move into a kind of whole new world of fabrication, which is much more open-ended than the tools that we were given 10 years ago. And so that to me is what's that sort of concern. I think people, they think that the sort of ethical issues of high-resolution renderings are somehow, it's sort of an end game, but it actually trickles into all of these other things that we've been doing, and students being led to believe that what they're producing is somehow going to be a perfect copy of what other people are doing who have real knowledge about how these technologies produce and fabricate things.
Yeah, I mean, I think one of the interesting parallels to to simulation is this robotic process of assembly, and the question is, with that, and it's again this sort of tricky question of the relationship between how much architects should equip themselves in order to intervene in that project intelligently and in an informed way, or how much they should establish prototypes which they can later guide. And I think this gets actually to sort of a fundamental question about reorganization of practice, right? So, like, to what extent should architects take on that project of design build in sort of like this completely automated way, or to what extent should architects designers attempt to create prototypes for machine process? Obviously now it's possible, more possible than it's ever been, and there are obviously sort of very dramatic examples of success in that arena as well. But as like for example, like the Fondation Louis Vuitton. So this is a project that I worked on in France, and that project, the entire process was basically in some way based on a sort of prototype of what could be achieved with glass. So there were some small-scale prototypes, and then the designers basically proposed a type of machine that could extend that could be scaled up to the level of manufacture for the building. So this isn't the case where they built the machine, but they basically guided the process of that machine construction and assembly to enable something that was unprecedented. So the question is not necessarily whether it's not. I don't think there's necessarily a clear position as to what the proper role of that is, but I think it's an open question as to what that could be.
Well, I think my curmudgeonly response there would be that we tend to valorize the strictly vocational aspects of this overmuch and lose sight of the architectural dimension, architectural question in all of this. We tend to confuse and this may be to Andrew's sense of a desire for greater humility on the part of the architecture students, but we tend to confuse their stumbling engineering efforts for architectural advances. And my fear in that case, as an educator, would be that the sense of the architectural intelligence begins to be dissipated or diffused into engineering problems, vocational problems. That, in my view, which is a longer view that maybe is an architectural view, but maybe it's just a view of somebody who grew up with a lot of science fiction and is not, as I mentioned to you earlier privately, so impressed with the state of play now among our shiny new toys and all that, and looking forward to a time when the kind of crude efforts at translation become much more seamless, and the desire of the designer is more continuously and effortlessly or transparently translated into stuff. You know, that may not actually be that far out. But my fear is that if we focus so much on, you know, again, with no disrespect to engineers, though, that engineering or all quantification-based disciplines are likely to disappear into expert systems in the future, leaving only fuzzy and ill-defined efforts like architecture remaining for directing this stuff. But in any case, if we focus on these, valorizing overmuch the technical side of this stuff, I think we lose track of what architecture has traditionally been, in the sense of how architecture is different, the sense of order that it deploys, the sense of organizational ability, and this sort of thing. You know, it just feels, you know, within the longer view that architecture encourages, even if it's a temporary construction, it seems to me short-sighted, you know, dangerous in that way.
Yeah, I think it's actually like, I think one of the lessons that we can learn from things like product design, product manufacture, things like that, is that, you know, exactly as you say, the things that can be automated and can be quantified will be. And so, to the extent that the designers are able to extend their control over that process as it happens, I think that will empower us to control that process more fully.
Right. Well, I would say just to defend myself a little bit in my own relative lack of skill in the more technical aspects of this stuff. You know, I think about it as when I was going to Berkeley, you know, and we were complaining about not learning how to draw the way the Cal Poly students did and everything. And one of the professors there said, you know, it feels bad now, but eventually they'll be working for you. And I think this is also true of the character or level or quality of the GSD education in the larger, you know, global picture of architectural educational possibilities and all that. So, you know, I console myself in my own a lack of interest in learning the latest release of, you know, Rhino or Maya or whatever it is now that's the bitchin' new software. Say that really I will hire these people who know this stuff, and they are to me like a mouse and keyboard. So I will communicate to them in the way that ultimately 20 or 30 years from now we will communicate directly with the machines, that is through gesture and word. I'll say, you know, we want to do this, and it wants to do like that. No, 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 a little bit more, okay, that's good, and that sort of thing. And I won't worry about the actual intricacies of the language required to input to the machine directly, because there will be somebody vocationally trained to do that for me, and that allows me, you know, for better or worse, to keep my head in the clouds, but they're architectural clouds, and to worry about what you're actually going to do with those skills at the end, rather than get all wrapped up in being able to make this thing go, you know, whatever.
It is, Wes, it's funny because, and I mean this in all seriousness, the way that you just described how you might talk to an employee is probably the way that someone who programs a robot thinks about communicating with that tool. I mean, I think that there are always moments for, whether it's sort of technological ineptitude or social ineptitude, and I think you discover in all of those things the kind of how you might unwind that process and let's say challenge your own sensibilities or your own intuitions, however, just to use the language that we've been using. And it's a little bit, I think it's disingenuous actually to say that there isn't a value in trying to figure out how one might communicate with anything, any tool, whether it's a person or a robot. And so,
but I see that asymptotically approaching the way that I'm already communicating, because the goal of the research in this area is to make it more natural, more transparent, more natural language commands, more gestural communications, more transparent directly to the will of the designer. Now the question would be...
I don't think that's necessarily true, actually. I think in fact a whole range of these experiments can themselves be provocations, experiments, right? They can be, their intention is actually to expand the scope of what the designer sees as possible. It's to educate the intuition, right?
Right, but this goes back to the point that I have a hard time at seeing anything that's put out there as most advanced as fundamentally newer than stuff that Kiesler was doing.
These things have been happening for 60 years.
Right.
We're on a specific trajectory, right? And I think a series of experiments have opened up which have actually broadened the range of that trajectory. So,
can I say something here? I like the fact that Moasen showed in his presentation the hand drawing slides, and the reason why traditionally we have been learning freehand drawing in architecture schools is not because we want to produce nice drawings, but because we want to train our eyes to be able to see colors and shapes. So we learn to see these things. So I'm not in favor of using the latest computational tool to create whimsical geometry, but I think engaging with the technology, with the infrastructure of the technology, affects our thinking process. For example, all the software that we are using now, all the interfaces that we are using, in most of our daily life, basically, are based on certain paradigms, like the object-oriented paradigm, the fact that people now think of the assembly and construction process as objects associated and the relations between objects. This all, to an extent, comes from the way the infrastructure is working. So the infrastructure and the engagement with the infrastructure affects us in more subtle ways.
Actually, I think we may need to wind things down soon, because I would like to open it up to some broader questions. But I mean, absolutely. I mean, I think essentially what's come. I mean, one of the key ideas that's come out of this discussion is actually the central value of design and design education, and the fact that these processes, which I think become sort of extensions of that design intent, are becoming more numerous, more general, more rich. Actually, as time goes on, and I think that's something that enables a new possibility in the way that design can be realized. So I wanted to thank our panelists, and also, I'm not sure actually how much time we have for questions, but there's enough. Yeah.
Wow, a lot of broad-ranging discussion and a lot of interesting comments. So my name is Scott Hodner. I teach at Parsons School of Design, and MDes 03, DDes 10. So I think that's an important point to make also. I found the whole discussion interesting, but also found, obviously they're very difficult to dive in deeply in one panel discussion, but the focus was on this word simulation, and it seemed that a lot of you were talking about simulation as a visual activity. And then towards the end, started to get to this question about how simulation is communicated to others. As it happens, communicating to a robot over time, people start to think of that robot and programming it as actual person. They don't think about it as a machine. This has sort of been validated in many ways. They start to think about it less as an artifact and more as a thing they're communicating with. Computers as well. So I was wondering if anybody would want to speak more about the word simulation and what it actually means. I would ultimately love some commentary on how the classroom, the environment actually that is being taught in the studio changes, if you have any thoughts about that as well. But really, I guess, to keep to the thread, the question of simulation beyond visualization. Who is it for? Why is it for? It seemed a lot of this discussion was about showing something to someone else, but the term visualization can mean so many more things than what a building looks like and how it interacts it. Even the question of Google, of goggles and gloves. Any walk down New York City street shows that digital media is already having a much more compelling effect on people in the world around them because they're spending most of their time looking down at their phones. So the way we think about that visualization happening is already sort of fundamentally shifted for most people in the world. So I was wondering if anybody wants to sort of dig deeper into the word visualization.
I would tell you, I'm not trying to monopolize things, but I will. Anyway, I would say that visualization, the one place where I feel very comfortable and interested in these tools at the nitty-gritty level is the point at which this extreme simulation visualization possibilities now can begin to refine our intuition about how things work, like structure or whatever. So even though at the end of the day it will be quantified and disappear into the machine can teach architecture students in the meantime through force feedback or through visualization how materials work. It can begin to actually inform the intuition. So in a universe, in a tectonic universe where you put things together and you span things with other things and things have to hold stuff up, our intuition is developed through our experience through life with doing just that. But as we proceed into a universe of composites and continuous differentiation and materials which are not tectonically understood but geometrically understood, we will need these tools, these visualization tools, to inform our intellect, because I think that in that universe there's a lot of counterintuitive structural possibilities, for example, in how stuff goes together that we would have no experience with playing with, before we get to architecture school, playing with them. But with the goggles and gloves or whatever it is, I think that though that virtual world could teach us in a way that we would otherwise have no ability to experience.
Yeah, and I think this idea of creating models, which of course designers are very familiar with, is replicated in many different contexts. And I think this is kind of what you're alluding to, that it's possible to create models for the type of systems that we're interested in investigating, which are not purely visual, but actually have some mechanical and material and performative qualities, and through that we can shape them more elastically.
It was Boeing, the 777, that was the first big simulation project to build a plane with no full-scale mock-ups to trust, feedback, and now they're making carbon fiber airframes also through the same process. At one level, the protecting of the public health is, part and parcel with clash tests of geometric surfaces, optimization, and so forth. So mostly there's a huge world that is obviously not about purely visualizing something to culture. The question I would have, just to kind of maybe throw something a little bit more political on the table, is I can see a future where materials work much better. We have access to all the tools we need. The conversation on the sustainable still goes on, but we've been more attentive to it. And in the set of possibilities that you refer to, which vaguely seems like the project of the avant-garde, although no architect today, including Frank or Zaha, everyone's disavowed the avant-garde project because it's bad politics. Does culture want us to continue to just do whatever we want with these things? Does culture ask us to do that? I don't want to moralize it, but there's moralization questions around it, which of course are way beyond the scope of what we're talking about here, but
That's
super important.
Yeah, that's a great question. I mean, I think a lot of the things that we're discussing are, of course, very much of the moment, and I think everyone can recognize that, 20 years down the road, there'll be a different set of questions to discuss. And I think, yeah, the sort of imperative of what does culture ask of designers?
Ultimately, though, it's
really,
not going to be culture, it's going to be the market. It's going to be money.
I don't think it's only that, right?
That's pretty cynical, Wes.
I'm
Very
sorry.
Do we have another question?
Josiah Kane, MDes 06, Design Technology and Environment. Very interesting discussion for sure. A lot of my work has to do with using technology to optimize ecological systems. So I had a little bit of trouble with the idea that sustainability, first of all, is about efficiency, and that therefore it's in conflict with this idea of an intuitive design that needs to be educated or informed. I think the fundamental conflict between those things is not the best approach, I guess. What I would say is I don't think that we can simultaneously romanticize the tradition of architecture and then sort of reject these optimization tools, because before we had the engineers, whatever that intuitional or quantitative design structure was, it had to use daylight to make buildings comfortable. It had to manage facades, materials, all of these ecological inputs. And so I guess the question I have is, rather than seeing this fundamental tension between efficiency, which really is just an environmentally integrated building, it can be efficient or not as long as its impacts aren't like reaching all the way across the planet, right? So it could be a high energy building if it has available energy, for example. So this idea of efficiency that is just taking away from design, I think, for me is problematic. So the question I have is really, how can simulation work to really resolve these conflicts, or perceived conflicts between different design inputs? And that's happening with BIM and all those things, but I'm just curious to know like where the front edge of the simulation might be providing that.
Can I say something here? Because the word optimization is often misused in a design context. Even in an engineering context, in strictly quantifiable projects, the optimal is a multiple. There is not a single multiple, a single optimal solution to anything. So it's basically, optimization is a heuristic process by which we try to find out the best outcome out of an infinite range of outcomes. In that sense, I don't think there is any contrast between using both the optimization tools we have, which are always very limited still in terms of what they can do with simulations. If you know the limitations of simulation, you know that they are not as realistic as they make you think they are. And the fact that we have a designer who intuitively selects outcomes out of all these possible optimal outcomes.
I feel like I have to jump in a little bit. Yeah, I think if you're interested in quantities and qualities of life in the 21st century, efficiency is just not the best tool to get there. And quantifications, I think, at least in terms of realm of energy, the more you get into it, the more you understand how much has been left out of the orthodoxy of energy within energy in architecture. And there's some really consequential things that have been left out, mostly the ethos, or what I might even call it, the cosmos of feedback. And I think we should be designing feedback, not necessarily implementing the wills of individuals focused on efficiency. There's a very different universe out there that's based on feedback and what you might call an optimized planetary system, very different than an optimized, let's say, component or system within a building. Any optimized ecological system has profound inefficiencies in it. They're in place precisely to keep it far away from equilibrium. That's how the whole system works. So again, I think looking forward, in my view, it's much more of a paradigm of maximum power design, maximizing the energy intake into a project, but also maximizing how much energy we're getting out of it, how much work we're actually getting out of it. It's a very different worldview about how energy systems operate. There might be efficiencies in there somewhere, but those are always under the umbrella of maximum power design.
I think we have time for one more.
Right here. Right here.
Okay,
One more brief and very pithy one.
Man, look at the blank phone. You're looking the wrong direction over here.
All right.
Michael Lair, class of 1978, and chairman-elect of the Alumni Council. A great discussion. It seems that as an older architect, when I go to the academy, there are avant-garde studios, which are, let's say, reasonably purely technological inquiries, and there are traditional studios which are grounded in sort of human experience and placemaking and transformation of the environment. And it seems that it is rare where that nexus, where the moment of truth happens, where it's like there's this wonderful exploration on one hand in the beginning of the semester, and then at the end of the semester, let's bring this into the city, and there's inevitably an extreme disconnect. And it seemed that for students with a limited time in the academy who have a future of shaping the environment, how do you see in the academy really focusing on that moment? I mean, it's really the moment between analysis and synthesis, but it seems to be very commonly today. I mean, it seems that it's possible to come through the academy and have very little of one or the other. I mean, as an older architect, I'm biased towards, sort of placemaking and using everything in the service of that. But I'm wondering, how do you make sure that our students come through with enough formative structuring in their architectural, landscape architectural brains to deal with that moment?
Good question. I mean, actually, as the one who actually spends the least time at the GSD of the faculty here, maybe if you guys would like to take that one on.
Well, I think it's simply to say that there are multiple requirements on any pedagogy today, and I think the work that Andrew is doing in a robotics studio is every bit real and sort of placemaking in a slightly parallel but directly adjacent way. And so I don't think we can. I'm really intrigued by Neil's observations about the kind of obligations towards a realist discourse in studios, because you see it both in the kind of robotics realm, you see it in energy realms, all these sorts of things, and so I think it's there. It may be less familiar, but I do think when we're sending a student off that had maybe Andrew's computation class and production class, and then the next semester they're in Africa with Francis Carey. I think they're getting all of these things in a really powerful way, and I think that's more than biasing either one. I think that's the great asset of the GSD, is to present this multiplicity of let's say, realisms, and students tend to find their way. And I know your son did too.
I think we're going to need to conclude, but I wanted to thank Yeah, maybe Michael makes it.
No, go ahead.
No, okay.
Conclude, yes.
Okay, well, anyway, I want to thank the panelists very much for the very stimulating discussion. I think there's a lot of all sorts of scope for investigation of this spectrum between fantasy and realism, and so thanks again.
Yeah, just thanks very much to Andrew for curating this panel. It's really good, and thanks especially for all the participants. Thank you very much. Just before lunch, one of the things that the thing we all appreciated as we came to this panel today was the landscape surrounding this building. And our own Neil Lehrer, MLA 79, is responsible for this landscape. I was going to ask her to say a bit about the landscape that she designed before we have lunch.
Well, maybe I should start out by saying that, and having been at the school at a critical time, I didn't just design the landscape. I worked with the architect to basically decide how the spaces would be shaped. But I, find myself sorry for being defensive. But for all the younger landscape architects in the room, I have to say that. So this part of the coast was called the Gold Coast. And Getty and Fairbanks and Woody and Randallhurst and many others had houses here. This particular house, and some of you might have been to the Getty Villa, that's where he lived. He had to actually go on a bridge to get down to the ocean. And this particular villa was built by Hearst for his girlfriend, Marion Davies. That house there was her mother's house from when they came here to vacation. And it was a 100-room villa. And so what's particularly interesting about this project on many levels, and for those of you who are not from California, Santa Monica is considered the People's Republic of Santa Monica. It's a very, I know we're a fairly democratic state, but also this city is, of all of 80,000, really believes in community, and fortunately or unfortunately for them, all 80,000 participate in the process. For any of you who have questions afterwards, what were the limitations associated with this site, in working with them, I can certainly do so. I do want to thank the GSD for, because at the GSD, of course, I met Michael, and it's because of him I came to California. Otherwise, I'd be living in Latin America, and it's a great place to live. And certainly, you can all see this, and I don't want you all to feel sort of jealous, but this is what the weather is like 99%. So we have an incredible history of strong landscape architecture, and sort of the sense that architecture and landscape architecture are inextricably sort of connected, and what this building is about about that. To put another part, when you're out there and you see a white line across the landscape, it's an interpretive moment. An interpretive moment, that's where the bulkhead used to be come up to. So all 450 feet of sand that you see there are a result of the bulkheads of the major infrastructure work that was done at the Port of LA in the 1940s. So if you want to think of sustainability and balance, just figure, obviously it gave us a lot. It gave Southern California this beach to enjoy, and it's a public space, but it's 450 feet of it that didn't exist before. So there's a tremendous amount of real estate. And one of the unusual things about Los Angeles that we have a nascent sort of public realm. We forgot to build schools, we forgot to build parks, and we forgot to build transportation for decades. Fortunately for us, there are many people, and some people are here, Martha's here, others are here, Michael was involved in the school system. We are sort of really growing and becoming a city that is able, many of you were yesterday downtown and saw some of that. So what actually this project was designed around was a business plan. The site had gone through an earthquake and a fire, and it had gone from being a private residence to being a hotel, a private beach club, and then eventually the state bought the land, and it was a decision was made to, there was a little blurb in the paper where the city had done some internal work as to what this place could be and what to turn it into, and do you develop it, what do you do? And Wallace Annenberg read the article, made a call, and said, so when we're talking about P3s or public-private partnerships, this is one of them. $30 million was donated to the project to build this facility. And the business plan, as I said, was all about how do you make this financially sustainable, and have all sorts of events. We're here today using several rooms. There are other things going on in other parts of the facility. There's evening weddings. There people come and convene here. And what's really important to let you know is this is where beach volleyball was invented. Not one. There are people that still come here who are in their 70s almost every day to celebrate that. So as we work together as a team, among the things we had a Julia Morgan pool, which is the beautiful 75-foot pool down in that next to the pool house, and then in the building that was in pretty good shape. Everything else was up for grabs, and how we basically massaged and created these spaces was all about rooms, what sizes, who would come here when, and how could we maximize the site and create a place. Obviously trying to pull back towards PCA, Pacific Coast Highway, for sound attenuation was also important. And it has become, I wish we could have simulated salt issues associated with plant material. We're about to engage in the next 3 months in a major replanting because we've lost a lot of plant material. I was really embarrassed that all of you were coming before the work was done. But just kind of put your glasses on. We've had a lot of loss, and it has to do with salt, and it's a place that's incredibly well loved. Loved to death, I would say. It's used so much, it's watered, there's a lot of issues. With that, I'm around. It's extremely well managed and programmed, and it is an example of a facility that is now in the public realm. Costs $20 to come here with your family. You have all sorts of private, and it's kind of ironic because it's also right next to the Jonathan Club and other clubs who never allowed Jews into the clubs, and this is funded by a Jewish philanthropy. So in any event, anybody can come here. It's sort of self-selected. It's interesting. Obviously, families from the inner city who could come here aren't comfortable. But it's very, people stand in line to get here. There's a capacity in the pool that gets held to. And it's just a regional destination, I would say, for people who want to come to the pool for the day. Thank you.